In this video, we will take you through deploying a HuggingFace question answer model on Kubeflow's KFServing model server system. We'll walk you through what is HuggingFace and then what is KFServing. We'll then explain how to deploy custom models on KFServing. We'll close the video tutorial with a breakdown on how to make inference calls to our deployed HuggingFace model on KFServing. HuggingFace is a leading NLP-focused startup with more than 1,000 companies using their open source libraries in production. HuggingFace is also a Python-based transformer library that exposes APIs to quickly use NLP architectures such as BERT, Roberta, GPT-2, and Distill BERT. This allows practitioners to achieve state-of-the-art accuracies on tasks such as information extraction, text classification, question answer, summarization, and text generalization. The included models in HuggingFace are generally pre-trained on a large corpus of data and fine-tuned for a specific task. This example uses the stock extractive question answering model from the HuggingFace transformer library. KFServing was designed so that model serving could be operated in a standardized way across frameworks right out of the box on Kubernetes. Kubeflow needed a way to allow both data scientists and DevOps teams to collaborate from model production to model deployment. KFServing's core value can be expressed as helps standardizing model serving across organizations with unified data plane and pre-built model servers. KFServing is a single way to deploy and monitor inference services and scale inference workloads. It can also dramatically shorten time for data scientists to deploy models to production. KFServing is installed with the base Kubeflow 1.0 install, or you can try it out with a standalone installer on your local machine, as we'll see later in this video tutorial. We're assuming you have a working KFServing install with Kubeflow 1.0 or later. However, if you just want to install the standalone KFServing component, you can check out our blog post linked at the bottom of the screen. It quickly gets you going with a Kubeflow cluster. I'll show you mine now running on the screen. If we do a Minikube status, you can see that Minikube is running as shown on the slides behind it. If you want to install the quick standalone version of KFServing on Minikube, follow the instructions in the article. They're also on the screen here. These instructions will show you how to clone the KFServing repository and then install it on Minikube. Once you have KFServing up and running, run the kubectl command at the bottom of the screen and it will confirm that KFServing is actually running, as we can see in the console output on the screen below. Let's check it live with my local install here. So we're going to run the same command and my existing KFServing resource on Kubernetes is indeed running. There are two main ways to deploy a model as an inference service on KFServing. We can deploy the saved models with a pre-built model server on a pre-existing image. There are many of these included with the stock KFServing project. We can also deploy a saved model already wrapped in a pre-existing container as a custom image. Most of the time we want to use one of the pre-built model servers included with KFServing, because it's the least amount of work for our engineering team. There are many pre-built model servers included with KFServing out of the box. With KFServing, our built-in model server options include TensorFlow, sklearn, PyTorch, and many more. Sometimes we'll have a model, such as HuggingFace, that will not wire up correctly with the pre-built images included in KFServing. The reasons this could happen include the model was built with different dependency versions than our pre-built model servers, the model was not saved in a file format the model server expected, and other API semantic issues. For any of the cases that don't fit into a pre-built container image for model serving, we have three options. We can wrap our custom model in our own container, where our container runs its own web server to expose the model endpoint. We can use the KFServer class as the web server with its standard TensorFlow v1 API, and then overload the load and predict methods. We can also deploy a pre-built container image with a custom REST API, bypassing inference service and sending the HTTP request directly to the predictor. Of the three options, using KFServer as the model server and just doing custom overloads will likely be the most popular route, as it's the least amount of work and includes its own web server. Given that HuggingFace has a unique Python API and a lot of dependencies, it does not work on KFServing out of the box. In this case, we need to do two key tasks. We need to create a new Python class that inherits from the KF model interface with custom methods for the load and predict method signatures. We need to also build a custom container image and then store it in a container repository such as Docker Hub. To deploy our HuggingFace model, we need a new model server class for the HuggingFace Question Answer model to implement the KF model methods. We also need to build our Docker container, and then we need to push our Docker container to Docker Hub or another container repository. Once we've done that, we can deploy the custom inference service to our Minikube Kubernetes cluster. On the screen, we can see our KFServing BERT QA model class that inherits from the KF model interface. We can see, if you look in GitHub, you can see the complete class. We're just showing a snippet on the screen here. There are two things happening in this code with respect to integrating with the model server. The first is the HuggingFace QA model is loaded in the load method. The second is we are implementing the predict method to take incoming inference input from the REST call, parsing the JSON inside of it, and then passing the parameters to the HuggingFace internal class reference. The second is we have implemented the predict method to take incoming inference input from the REST call and pass the parameters to the HuggingFace model instance. The HuggingFace model we're using here is technically the BERT large uncased whole word masking fine-tuned squad model. This model and its associated tokenizer are loaded from pre-trained model checkpoints included with the HuggingFace framework. Next, we need to build our Docker container for the model server. On the screen, you can see our Docker file. Once our model serving code is saved locally, we will build this new Docker container image. And once we've built this container locally, we want to push it up to a container repository, such as Docker Hub. Now that we have the code built into our Docker container, and the container is in Docker Hub, we want to deploy our custom model server on KFServing with kubectl. To do that, we have to put together a custom YAML file to define our custom resource in YAML for our inference service. You can see the YAML code on the screen. There's two parameters that I'll call out. The first would be kind, which is inference service, and the other would be metadata.name, which is KFServing custom model. To deploy our custom inference service QA model with kubectl, we use the kubectl command shown on the screen. The command sends the YAML file from the previous page to our Kubernetes cluster. After we wait a few seconds, we want to check to see if we actually deployed the inference service correctly. We use the kubectl command, kubectl get inferences, and we should see model output similar to what we see below. Let's actually make sure that that is what happened with our local install. And we can see KFServing custom model is ready. Now let's make an inference call to our locally hosted HuggingFace QA model on KFServing now that we know it's ready. As a side note, if you're using the local Minikube demo version of KFServing, you may need to do some port forwarding work so your model's port is exposed to your local system as described in the companion blog article. I'll note that in this demo I'm actually doing that, and I'm using the port forwarding command in a separate shell with kubectl. For this example, we're going to use some custom JSON our model server is coded to understand, as shown on the screen. Since we control the model server implementation, we can take arbitrary JSON and feed it to the model correctly in our code, which we've done in this example already for you. Using the command at the bottom of the screen, we send this JSON input to our deployed model via the curl command. As you can see on the screen, this is what you should see. And now let's check to see that this actually works. This is the same command from the slide. Here in the console output, you can see the answers returned from the server question answer model, where the model replies over 32 when asked how many pre-trained models are available in transformers. This model is able to summarize and extract an answer from a small snippet of text. Pretty impressive. Thanks for watching our video on deploying the HuggingFace Question Answer model on Kubeflow and KFServing with NetApp's ONTAP AI.